Hi, my name is Jennifer, and I'm doing my assignment on related rates with a focus on word problems. My method to solving most word problems involves an acronym called DIET-SS. Now, each of these letters represent steps that you want to take for when you solve word problems. D stands for draw, and that just involves you drawing the picture or drawing a picture that the word problem is talking about. I stands for identify. So the next step you're going to want to do is identify all your known and unknown variables. The third step is an equation. So this step involves you trying to find an equation that relates all the variables together. So for example, if the word problem is talking about the area of a rectangle, you're going to want to use the equation length times width to get the area of the rectangle. T stands for take the derivative. This step involves finding the derivative of this equation. The next step is to substitute. So this is where you're going to take all your known and unknown variables that you identified here, and you're going to plug them into this derivative equation that you did here. And the last step is to solve. This requires you to just calculate everything that you've plugged in here to solve for the variable that you need. So the word problem I'm going to use now is this one. Okay, so suppose the radius and height of the cylinder are changing with respect to time t. At a certain instant of time, the radius and height of the cylinder are 2 and 6 centimeters and are increasing at the rate of 0.1 and 0.3 centimeters per second, respectively. How fast is the volume of the cylinder increasing? So we have to pick up on some keywords here, such as radius and height. And the radius is 2 and the height is 6 centimeters. And we have to take note that they are both increasing at the rate of 0.1 and 0.3 centimeters respectively. The question is asking us to find the volume of the cylinder. And because it's telling us that it's increasing, that means we have to find the derivative, or v prime. So the first step that I did was I drew a picture. I drew a picture of the cylinder. So here I put in a radius of 2 and the height of 6. Now we have to keep in mind that both the radius and the height are functions, and they are both changing with respect to time, as is stated up here. The second step involves us identifying all of our known and unknown variables. So we are told that the radius is 2 centimeters and is changing at a rate of 0.1 centimeters per second. And the other thing we are told is that the height of the cylinder is 6 centimeters and that it is changing at a rate of 0.3 centimeters per second. And the question is asking us to find the volume of the cylinder. And we know that it is increasing, so the answer should be a positive number. So this means we have to find v prime. Now, the next step involves us finding an equation that relates all of these variables together. And in this case, we're going to be looking at the volume of the cylinder. The volume of the cylinder, the equation to the volume of the cylinder is equal to pi r squared times height. Pi r squared represents the area of a circle, and if you multiply that area of the circle times the height, that will give you the volume of the cylinder. And we also have to remember that this term here, pi r squared, is kind of like the value 3x squared. Pi is just a number. The fourth step is to take the derivative of the equation. So, in order to take the derivative of this equation here, we have to notice that we have to use product rule. And product rule is f times g prime plus g times f prime. That is the general format. So I've color-coded it that f is blue and the g is purple. So here, I'm going to start to find the derivative of this equation up here. So, pi r squared stays the same here. The derivative of h is just 1. So if you want, you can put in 1 here, or you can just leave it out. But because h is a function of time, we have to remember to add h prime. The next part is h stays the same, and now we have to find the derivative of r. So we have to find the derivative of this part here. So we have to bring the 2 down. So the 2 comes down, and pi stays the same, and r squared becomes r to the 1. So I'm not going to write 1 up here. I'm just going to leave it like that. But because radius is also a function of time, we also have to include r prime. So we can just organize this a bit. And if you want, you can simplify this quickly. So pi r squared times h prime plus h times 2 pi r times r prime. And now, what I want to do is I'm going to quickly simplify this, just so that it's easier to solve later on. So to simplify this, I'm just going to factor out the variables pi r. So pi r I'm going to factor out. Oh, maybe I should just put this back to capital R. Okay, so